Next up in our discussion, we're going to look at the magnetic force between two current carrying wires. And I have illustrated for you here a wire in orange with a current that's flowing right to left in your picture, and a current in purple that is flowing left to right in your picture. As you know from our previous discussion, both of these currents create a magnetic field. We saw the equation for the magnitude of that magnetic field, and we'll see it again in just a little while. But let's take a moment to think about the direction of the magnetic field created first by the orange wire and then by the purple wire. What rule did we learn that's going to help us figure out the direction of those magnetic fields created by those wires? Take a moment to think about that. If you were thinking about the second right-hand rule, as we refer to it in class, then you're absolutely right. Think about the second right-hand rule. I'm taking my right hand, I'm pointing my thumb in the direction of the current flowing in the wire, and we'll see when my thumb is pointed this way above the wire in my picture, the field is going into the board. So we use our symbol for a vector going into the page above the wire. And, of course, below the wire, if I could reach around underneath my whiteboard here, you'd see my fingers are coming out of the board, so we use our symbol for a vector coming out of the board or out of the page. And we notice that that vector exists everywhere on the bottom of my whiteboard and beyond, just like the vector on this side exists everywhere on the top of the whiteboard and beyond, just decreasing in magnitude as I move further and further away from the current carrying wire. So now I want to know, what is the direction of the force felt by the purple wire? The purple wire, which is bathed in this magnetic field created by the orange wire. So take a moment, see if you can remember how we would find the direction of that force. If you were thinking about the first right-hand rule, the right-hand rule we use to show direction of force, current, and field relative to one another, you'd be absolutely right. Using my right hand, I've got the field coming out of the board, as we can see. My thumb is in the direction of current, and we'll notice my palm then would be pushing down towards the floor, which means the force the orange wire's field exerts on the purple wire is down. Meanwhile, the purple wire is exerting a force on the orange wire. Maybe you can go through the same exercise we just did. Think about the direction of the field that the purple wire is creating where the orange wire is, and then think about the direction of the force that the orange wire must feel as it carries this current in that direction. So take a moment and think about that. And we're back. Up here where the purple wire is, the field above the purple wire in our picture is coming out of the board. And of course, the orange wire is bathed in this field that is coming out of the board above the purple wire. Again, I use my second right-hand rule. I imagine myself grabbing the purple wire, and we see above the wire, my fingers are coming out of the board. And of course, below the wire, my fingers would be going into the board, but we don't really care about what's happening down there. There's not much of interest down there. So now, field's coming out of the board, current's going right to left. Look which way my palm is pushing. It's pushing up on the whiteboard. Oops, didn't mean to pause yet. I had to ask a question first. But you knew that already. Do I really need to go through that whole exercise and use all this purple and orange ink to prove that to you? Think about that for a second. Any thoughts on how we could have known the direction of the purple one once we knew the direction of the orange one? That's going to be a homework question for you. So think about that and answer it as part of the homework for this particular installment in our remote learning plan. Thank you.